on 8.2 forces on momentum is, well, momentum as well as Newton's laws of motion. So momentum, or P, measured in kilogram meters per second, is equal to the product of mass and velocity. So that's the formula, P equals mv, that you'll have on your data booklet. Generally speaking, you'll never have to define it, but a definition of it is just, I guess, a measurement of how hard it is to stop the motion of an object. And you just remember that momentum is also a vector quantity, which means that there's a direction to it. It can be positive or negative. Impulse, which is written as J, refers to the change in momentum, or can be also written as delta P, change in momentum. There's an important law. There's the law of conservation of momentum, and it states that within a closed system with no other external forces acting upon it, the total momentum in the system always stays the same. Now, one way you could visualize it is say you have two objects, one here, one here. They both have equal mass. They're both moving towards each other with the same velocity. So that means that this one will have if they have a mass of m and a velocity of v, then this one's moving in this direction with a momentum of p, or a momentum equal to mv, whereas this one's moving in the opposite direction, which means that the velocity is negative v, which means that the momentum of this object is equal to minus mv relative to this one. And so the total momentum in this system is, well, the sum of each momentum vector of the objects, and that would be mv moving in this direction plus mv moving in that direction. And because that's in the opposite direction, that would be minus mv, which means that the total momentum of that system is 0. That's how you can think of it as. And now moving on to Newton's laws of motion, you have Newton's first law, which states that a body which experiences a net force of 0 will either remain motionless or continue to move at a constant velocity, meaning that it won't accelerate. And that's, I guess, it's a good segue onto Newton's second law, which states that the net force of a body is equivalent to the product of mass and acceleration, and it's all, or as you can see here, F equals ma. It's also equivalent to change in momentum, which is impulse, divided by change in time, which, as you can see, is equal to delta p, or j, divided by delta t. As you can see, they are these talk about opposite situations. Newton's third law states that when a force is exerted on an object, said object exerts a force of equal magnitude but in the opposite direction in return. For example, that explains the origin of the normal force. You have, say, a table here and a ball. The ball is on the table, exerting a gravitational force on the table, and the table in turn exerts a normal force back onto the ball of equal force, of a force of equal magnitude but in the opposite direction to the gravitational force. And that's it for momentum and Newton's laws.